welcome to my channel. Today we discuss about Poisson distribution. In previous video we discussed about binomial distribution, and in that we discussed two types of problems. One is in tabular form and another is in matter form. The question is not in the tabular form, and today we discussed about Poisson distribution. The overview of Poisson distribution is: this is the definition of the Poisson distribution. A random variable x is said to follow a Poisson distribution. It assumes only non-negative values, and this is the Poisson distribution formula. Formula e minus lambda power x by x factorial, where x is from 1, 2 and so on, and like numbers. And this is the Poisson distribution. Here we discussed about the problem in the tabular form. That is, this is the form of the table. Here the question is given this: find the Poisson distribution. We know that the Poisson distribution formula, it is e minus lambda power x by x factorial, just as similar to binomial distribution, but here the formula is this and the binomial distribution has the formula of that. And here the similar process is about mean, where n, p, q we find out the values, but here only we find out the n, p value and also the value of lambda. Just now we can start the problem, where n is equal to capital N, the sum of the y, 142 plus 156 plus 69 plus 27 plus 5 plus 1, which is equals to 400, is the 400. And mean is equal to, already we know the formula of the mean, 1 by n into summation fi xi, which is equals to 1 by 400 into 0 into 142 plus 1 into 156 plus 2 into 69 plus 3 into 27 plus 4 into 5 plus 5 into 1 equals to 1. The value will be 1. And here we find out the mean of the lambda, normal lambda value, equal to 1. Now we know the Poisson distribution, where capital N into, here the formula capital, here the value is in the tabular form, we have the n, capital N value. So for that we taken as capital N into e minus lambda into lambda power x by x factorial. In these we substitute the values from the probability for each one is p of x equal to 0, p of x equal to 1, p of x equal to 2, p of x equal to 3, p of x equal to 4, p of x equal to 5. This is the probability of for each a1. Now we can find out the values for each of the one. First one, p of x equals to 0 is equal to, n means 400 into the e minus lambda value. What is the lambda value? 1 into power x, x means x value is taken as 0 by 0 factorial. The value is 144. Next we find out p of x equal to 1 equals to, similar to p of x equal to 0, 400 into e power minus 1, x value is 1 by 1 factorial, equal to, the value is 148 or 118. Now probability of x equal to 2, which is equals to 400 into e power minus 1 factorial, 2 by 2 factorial, 1 power 2 by 2 factorial. The value is 74. P of x equal to 3 equal to 400 into e power minus 1 power 3 by 3 factorial, equal to, the value is 24.6. It is equals to 25. P of x equal to 4 is equal to 400 into e power minus 1 power 4 by 4 factorial, which is equals to, the value is 6.1 equal to 6. P of x equal to 5 equal to, the value is 400 into e power minus 1 power 5 by 5 factorial. The value is 1.2 equal to 1. This is the probability of x equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, x is equal to 5. And in Casio, the value of e will be shown when you type in the Casio. Now then we can easily to solve these in the Casio. The value is shown 74 for particular problem. This is the Poisson distribution in the tabular form. Thanks for watching.